Today's notes are Unit 3, Day 4 notes on finding the intercepts and zeros in functions. But first we'll do a quick function review. So if we look at question 1 here, it says if f of x equals 2x squared plus 1, find the f of negative 2. So remember, this is just a label, f of negative 2, and I'm saying negative 2 is the input. Negative 2 is going to be the x value that I'm going to evaluate for. So I just plug in negative 2 any place I have an x in my first expression. So I'm going to say 2. Since I'm using a negative number, I want to be especially careful. It is negative 2 that I'm going to square. And that's important because negative 2 times negative 2 is positive 4. So if I have 2 times 4, that's 8, and 8 plus 1 is 9. So if f of x equals 2x squared plus 1, find the f of negative 2. The f of negative 2 is 9. That's our final answer. If I let f of x equal 2x minus 3, then I can figure out what x would be, what would be my input if the f of x equals 13. So again, I'm telling you my output, so I could say y equals 13 here. My output is 13. So I'm going to rewrite, instead of saying f of x equals 2x minus 3, I'm going to say 13 equals 2x minus 3. 13 equals 2x minus 3. I'll add 3 to each side, so 16 equals 2x. Divide each side by 2, and I will get 8 equals x. So 8 is my final answer there. Right? Number 3 says that the function g is defined as g of x equals all of these ordered pairs. So we have a function that has discrete points that are given to us. What is the g of 3? Remember again, the 3 is in the parentheses. In is our input. So if my input was 3, that means my x value was 3. Right here, my x value, my input is 3. So the g of 3 is negative 6. That's my answer. It says state another ordered pair that could be included in this set so that it would remain a function. The only thing that would make it be not a function is if I repeat one of my x values. So all I need to do is find a different x value, something that's not already there. I could say 0, 5, right? I could say 6, 7, anything as long as I'm not repeating my x values. There are many, many, many options there. Okay, so that was kind of a function notation review. Today we're going to talk about intercepts and zeros. So you already know y-intercept. We've talked about the y-intercept, and that's where we cross the y-axis. In this unit, we're going to talk about the x-intercept. And the x-intercept is where we cross the x-axis. So, of course, anytime you're crossing the x-axis, if you're looking for an ordered pair for that, you know that you have some number for x, but the y value in your ordered pair has to be 0, right? It always has to be some number, comma, 0. Okay? Or that means y equals 0, so my whole function value, the output has to equal 0. So an x-intercept is just what was the x that made the whole thing equal to 0. That's what we're looking for. So x-intercepts and zeros are really the same thing. It's a 0 because it is whatever my input value was that made the whole output 0. All right. So that's the x-intercepts. X-intercepts are zeros. Y-intercepts are just simply y-intercepts. That's all they get to be. They are not actually called zeros. Zeros means something different. Okay, so the y-intercept is just a point where you cross the y-axis. The coordinates of a y-intercept are 0, your x value has to be 0, and then some value for y, so that you are going to cross the y-axis at some value. All right. Normally when we talk about zeros, again, that is the input that makes the whole thing result in 0. The input that makes your output be 0. So I usually just give a numerical value for a 0. When I'm talking about intercepts, I usually want to write down an ordered pair, but there is some wiggle room there. So, all right, remember the zeros, all we care about is the x-axis. We want to know what's the value on the x-axis that makes our y coordinate 0. Okay, so my zeros here, there's actually only one this time. I cross the x-axis right here. Zeros, where do you cross the x-axis? I cross the x-axis right there at 2. So, what would my x-intercept be? It would be that ordered pair at 2, 0. Okay, it's the same information, it's just written in a different way. Zeros, I normally am just asking for the number. Intercepts, I'm normally asking for the ordered pair. Okay, then it says, what's my y-intercept? Well, this time I'm going to look where am I crossing the y-axis, and I'm hitting that y-axis right there when y equals -2. So my x value in the ordered pair would be 0, and the y would be -2. So notice every time you have an x-intercept, you have some value x, 0. Every time you have a y-intercept, you have some value in the x, or sorry, you have a 0 in the x, and some value for y. Okay, this time we only had 1 0, only one x-intercept, but if we look at our next problem, you can see that we are crossing that x-axis twice. What are my zeros? Those are the numbers where I cross that x-axis. So my zeros are 1 and 3. I'm going to tell you it's the set of numbers that includes 1 and 3, so I'm using my curly braces. All right, so what are the x-intercepts? Well, those are the points at which I have a 0. So the points at which I have a 0, I'm going to say this would be 1 0, and over here this would be 3 0. Those are both x-intercepts. Those are both places where I have a point that is on the x-axis. My y-intercept, that is, and sometimes there could be more than one, although it wouldn't be a function, right? Because that would be two things on the same vertical line. My y-intercept here, I'm crossing that y-axis right there at 3. So my y-intercept is at 0, x and y, 0, and then up 3. So I get to say 0, 3. All right. This one, what's my 0? Where do I cross the x-axis? Right here. My 0 is at 4. So x-intercept is just what's the ordered pair that tells me that. It's going to be 4, 0. All right, what's my y-intercept? Well, I'm crossing right there, so that would be at 0, then 1, 2, 3, 4. That's 0, 4. Okay, and this last guy, of course, these two shapes are called parabolas, which we'll work with later in the year. This parabola, or this shape that we've drawn, it is only hitting the x-axis in exactly one spot. See that? It is hitting that x-axis right there at 2. So my 0 is 2. And the x-intercept is the ordered pair that talks about that 0, so I'm going to say that that is 2, 0. My y-intercept, the only place I'm crossing y, is right there at 4. So that would be 0, 4. All right. So when we talked about function notation and evaluating functions, we evaluated functions algebraically, so plugging in values either for the input or the output. We also evaluated functions by looking at tables and then by looking at graphs. So we're going to find our x-intercept or y-intercept if we can by looking at a table. So right here, the x-intercept occurs when that y value in the table is 0. So you can draw yourself just a little coordinate grid image, oops, except for you want to be able to see what I drew. And you can think, okay, if I have a line like this, this is my x-intercept. So, and oftentimes I do this just to remind myself, whatever that is, that might be like -3, 0. Whatever it is, that's my 0, right? That's my x-intercept. And so I'm just looking, if I write that ordered pair out, I can remind myself that the y value in the ordered pair is going to be 0. Okay, so I am going to look at this table, and my y value, or my output, this is my output, right? I want my output to be 0. Okay, so, oh look, here's a 0, and always look for more than 1. There's another 0. So it looks like I have 2 x-intercepts. Right? So if I identify the x-intercepts, I'm going to say one of them is -4, 0. And the other one is down here at 4, 0. It also asked me to find my y-intercept. So I know the y-intercept is where I have a 0 in the x position. So in my input. If my input is 0, my output is 8. So that's my that's my y-intercept, 0, 8. All right. Remember, your x-intercepts, those are the zeros. So if I wanted to say, what are the zeros from this table, I would just say -4 and 4. Or you can use the ordered pairs. Right. To find the x-intercept or the 0 of the function, if we're doing this algebraically instead of looking at a table, we know that the whole thing is going to have to equal 0. 0 is going to be our output. Output is either the y or the f of x. So I'm just going to say y equals 0, or I'm going to say f of x equals 0, and then solve back to find out what the x would be, okay? And we'll ignore y-intercept statement for just now. So I'm just going to say I'm going to find the x-intercepts. So for the x-intercept, that means, looking back up here, the whole thing has to equal 0. So y equals 0. I'm just giving myself a reminder. To find the x-intercept, I know y equals 0, or the output equals 0. Okay, so if my equation was y equals -7x minus 4, I know to find the x-intercept, I'm just going to say 0 equals -7x minus 4. Then I'm going to solve that, right? Add 4 to each side. 4 equals -7x. Divide each side by -7, so I have -4/7 equals x. Okay? It asked me for the x-intercept, and usually when I ask for intercept, I'm asking for an ordered pair. So I can write this as an ordered pair. My x is -4/7. Of course, I already know my output has to be 0, but of course, I can see that I made y equal to 0, so this is the x-intercept right here. All right, now back up to the top here. It says find the y-intercept algebraically. Okay, so if I want the y-intercept, again, my x has to be equal to 0. So when I find the y-intercept, I know that that means x equals 0. So I'm going to plug in 0 any place I see an x. I started out with y equals -7x minus 4. So this time I'm going to say y equals -7 times 0 minus 4. 0 minus 4 is just -4, so I know y equals -4. All right, when I want that intercept, I'm usually going to write it as an ordered pair. I know x is 0 because that's how I defined it, and the y value I calculated out is -4. So there you go. All right, so if I want to find the x and y intercepts of this equation, y equals -8x, I'm going to say my x-intercept, I know that means that y has to equal 0, or f of x has to equal 0. Right? And so I'm going to say 0 equals -8x, which means that x equals 0. That intercept happens to be at 0, 0. That's at the origin. Whatever this graph is, it's going to go right through the origin. So my x-intercept, or my 0, is right there at 0, or 0, 0. My y-intercept is what happens when x equals 0. And so I'm going to plug that in. Y equals -8 times 0. And of course that just means 0. So it turns out my y-intercept is also 0, 0. All right. If I look at this next problem, we're going to find the 0 of that function. If I'm finding the zeros, I want to know what is the value that I had to put in to make the whole thing equal to 0. So this just means the f of x equals 0. All right, so 0 equals 2x plus 2, -2 equals 2x, and -1 equals x. So I'm asked to find the zeros, so I would typically just say my answer is -1. If you're specifically told to put your answer in ordered pairs, you would write out -1, 0 as the ordered pair. Find the 0 of this function. That means the whole function equals 0. So 0 equals 3/8x minus 8. I will add 8 to each side. 8 equals 3/8x. To get rid of that fraction, I'm going to multiply by its reciprocal. Okay, and so I'm going to multiply each side by the reciprocal. So that means that this is just one single x, and then I have 64/3. Ugly but true. Okay, if I want the 0 of that function, I want to know what was the value of x. I would just say 64/3. All right, there are some special cases when we have horizontal lines or vertical lines. And so if I have an equation that says y equals -1, then what that really means is for any x, y equals -1. So it's all of the ordered pairs, doesn't matter what x is, where y is -1. So I could be like -2, -1, 0, -1, 1, -1, 4, -1. So if I plot all of these ordered pairs where it doesn't matter what x is, but the y is always -1, you can see -2, -1, 0, -1, 1, -1, 4, -1. You can see they're all making little dots on that horizontal line. If you see y equals -1, you know you have a horizontal line. So the x-intercept is going to be, again, where do I cross that x-axis? Well, I don't, so I'm going to say none. There is no x-intercept, right? It doesn't ever cross that x-axis. There is a y-intercept, though. I'm crossing the y-axis right there at -1. So my y-intercept is when x equals 0, y equals -1. Okay, and because it's an intercept, we're asking generally for ordered pairs. Over here, a different kind of line. This one is x equals 3. Notice this one is vertical. So I could put a bunch of ordered pairs where the x value is always 3, and it doesn't matter what the y is, and you'll see that it's a vertical line. So the x-intercepts means where am I crossing this x-axis? This is my x-axis. So I am crossing right here at x equals 3. So 3, 0 is going to be my x-intercept. My y-intercept does not exist, right? There is no y-intercept because I never cross that y-axis. You have some classwork to check on, and then you'll have homework in MathSpace, so be sure to look in Schoology for your homework in MathSpace. And in the next video, I'll go over classwork here.